Hello everyone. Hello everyone. Today we are going to work on section 16.2, that is on line integrals. The formula for finding the line integrals is this. So let me introduce the concept of line integrals. When you say integral a to b f of x dx, I mean this is what you studied in Calc 1. What you mean by that geometrically is your domain is a to b, it's a line segment, and there is a curve on the top, and you're finding the area here, right? That's what it meant. Now the line integral here is over the curve f of x y ds means instead of the interval AB, you have a curve. So instead of the domain being AB, you have a curve. So it is a curve like that. And your function f of x y is projected onto this whatever this function f of x y here is. F of x is on AB here. Here the function is on the curve. So your domain is not an interval anymore. It is a curve. So it's basically, that's why it said in your textbook or some literature refers to it as, it is sometimes useful to refer to this as a curve integral, but we refer to it as line integral. Here the C is the domain, so we are integrating the function on the curve, not on the interval. That's the first thing. The next thing is here you will get area under the curve, right? That is the interpretation, area under the curve. But here what you do is, if you find the line integral, what you would get is instead of getting area, you would get the area on one side of the fence. I'm not able to draw the picture correctly, but on one side of the fence or the curtain. That's what it is. Okay, curtain. Okay. Now here when you evaluate AB, there is only one way you evaluate A to B. You are going in the increasing direction from left to right. So let's say if you want to go A to B here, let's say your curve starts at A and ends at B, you could go along the curve, or you could go along the straight line, or you could go along the parabola. There are many ways you can travel A to B through three different paths. There are more paths, but I drew three different paths. Now the third is here the value changes with the path you take. That's what is the next thing. Value changes with the path you take. Okay. So it really is important as to what you are really considering. Okay. The next thing is, there are several ways you can represent here. This is the line integral is represented by, I hope I will be able to do justice here, but integral over C f of x y ds. You cannot have line integrals for a function of one variable. You can have line integrals for a function of only two variables or three variables. Okay, one of the thing is you can go A to B. You can write this as f of x of t in y of t. I mean, if there is a z, then you can write z of t square root of you can have dx over dt squared plus dy over dt squared, and you have this to be a dt here. This is your arc length. Okay, this is your arc length. So this is finding the line integral along the arc length parameterization. You can also find arc length using another formula. F of x y ds is going to be, you can also refer to this as depending on the formulation A to B, you can write this as f of x of t y of t. What if y is constant? Then you get x prime of t, and then you get dt. That's one way you can get it. Or you can also get it as f of x y ds is going to be integral A to B. You can write this as f of x of t y of t then you get y prime of t dt. That's another way you can get it. Okay, then you can also write this as thinking any other way. These are the three different ways, and a line integral is basically one of the application is you want to find work done, you always use the line integral. It is f dot d, so in the calc 3 sense it is going to be the line integral of f dot dr. So that means it is going to be integral over c, how do I say it, f of r of t dot r prime of t dt, that we are writing it as f dot dr. The another cool comparison I can give you is if you set one of the variables, I mean let's say if you set y equals 0 here, then what you get is line integral over c f of x 0, then this is going to be ds is going to be y 0, so this formula goes away, then you get dx, so this is going to be f of x 0 dx, so this is going to be very similar to integral a to b f of x dx. So when y is 0, the line integral becomes a regular integral in calc 1. So I hope this is clear. This is a good enough in an introduction for line integral. So let's go on work on one of the problems here. Here evaluate integral y, integrate this, where c consists of a line segment from that followed by the vertical line segment c2. So you want to find your c is basically broken down into two ones. One is c1 first and then c2 next. So first is our goal would be to evaluate the line integral on c1, the next would be to evaluate the line integral on c2, then add it, then get the answer. Okay, so how would I go about it? So I want to evaluate line integral over c1, so that's going to be y dx plus z dy plus x dz. Okay, where c1 is a line segment from 2 0 0 to 3 4 5. Okay, so now what are my options? My options are, you see, I can either go with this one, I can go with this one, I can go with this one, or which one should I go with? That's the question that I have right now. But I don't have the value for x, I don't have the value for y, so now the goal would be to come up with the values of x and y. So how do I come up with the values of x and y? You know the line plane connecting or the line joining these two would be r of t is going to be 1 minus t r naught plus t times r1. So that means this is going to be your r naught, that is going to be your r1, so that's going to be 1 minus t 2 0 0 plus t times, you get 3 4 5. So that's gonna be you get 2 minus 2t 0 0 plus 3t 4t 5t. So that's gonna be, you get 2 minus that's gonna be 2 plus t, and this is gonna be 4t and a 5t. Okay, so this is your r of t, so which means you have x is gonna be 2 plus t, and you get y is gonna be 4t, and z is gonna be 5t. Okay, so your x prime is gonna be how do I say 1, your y prime is gonna be, okay, here 0 is less than or equal to t is less than or equal to 1, because when t is 1, when t is 0 you get r naught, when t is 1 you get r1, that's right. So y prime here is going to be 4 dt, or in other words 4, z prime is going to be 5, so we are going to use that. Okay, so now here the way I'm going to write that is going to be how do I go about writing it? This is going to be I'm going to replace this as integral from 0 to 1. See, I have integral on c1, but because I have reparameterized my values of t are varying between 0 to 1, so my limits of integration is 0 to 1. Here y will be replaced with 4t, so I can write 4t. Dx prime is 1, so dx is going to be just a dt, plus z is going to be 5t, so that's going to be 5t. dz is going to be 5 dt, plus you have x is going to be 2 plus t, dz is going to be again dy is going to be 4 here. This is good, this has to be 4. X is going to be 2 plus t, and dz is going to be 5 dt from here. Okay, you see now I have changed the line integral in using a parameter t, and I'm on the integral 0. My domain is from t equals 0 to 1. Okay, so that's going to be integral 0 to 1. This is going to be 4t plus 5t times 4 is going to be 20t, plus here it's going to be 10 plus 5t dt here. Okay, and that's going to be integral 0 to 1. You get 4t, 24t, 29t, so you get 29t plus 10 dt. Okay, so integrating term wise, you would, I'm just going through dt plus integral 0 to 1, 10 dt. I hope I'm on the screen. If not, I'm sorry. So that's going to be 29 t squared over 2, where my limits of integration is 0 to 1, plus my the other one is 10t, where my limits of integration is 0 to 1. So that gives you 29 over 2, 1 minus 0, plus 10 times 1 minus 0. So that's going to be what, 29 over 2 plus 10, which is going to be 49 over 2. Okay, so the value of the line integral over C1 is 49 over 2. That means the area of one side of the fence or the curtain is going to be 49.2 square units. Okay, now but then we are not done. Why are we not done? We want to evaluate the line integral over the curve C2. Now C2 is going to be, as we can recall, is going to be what? C2 is going to be from the recall is from okay, there seems to be some problem in my recording, and that's why I went off. So I hope this is continuing and you're all fine. Let's go with this one now. What is that I want to do? I want to integrate over the curve C2 from 345 to 340. So I can again reparameterize it from, let's say from I can consider this as R0 and R1. I can reparameterize it, go for that, or in other words, you can see that my x value is not changing. It's from 3 to 3. My y value is not changing, it's 4 to 4, but my z value is changing from 5 to z. So that means here you can see that my x equals 3, but my dx is equal to 0, my y equals 4, and my dy is equal to 0. So my z would remain. So in this case it would be what is that, 4 times 0 plus z is gonna be z times 0 plus x is gonna be 3 times dz, where my z is varying from 5 to 0. So you see it's not from 0 to 5, it's 5 to 0. Okay, my video got interrupted again, so I hope I will be able to finish this again. Okay, so that's going to be from 5 to 0. This is going to be 3 dz, so that's going to be 3z. Upon substituting the limits 5 to 0, you get 3 times 0 minus 5. That's going to be negative 15. So now the evaluation of line integral on the C is going to be from over the C1 plus over the C2. And over the C1 I got it to be 49 over 2, and over C2 I got it to be minus 15, so that's going to be 19 over 2. So that's how you evaluate the line integral. I hope this is helpful to you. If you have any questions, let me know. So I'm sorry that my video got interrupted a lot of times today. I'll try to fix it and hope to come back to you with a new video. Okay, take care, bye bye.